You are welcome to the Jamb 41's channel. In our mathematics class today, we are going to give attention to joint variation. Joint variation is type 3 of variation, a topic that we are looking at in our mathematics class. You will recall in the previous maths class, I taught you about inverse variation, where it was explained that this variation relates two quantities inversely. How? As one is increasing, the other will be decreasing. I want to believe that you had already taken this lesson, the previous lesson on inverse variation. If not, kindly consider doing so before you proceed with this particular class on joint variation. In this video, we are going to consider what joint variation is. We're going to look at how joint variation is being applied in certain cases. We're also going to give attention to how to apply the knowledge of joint variation in solving problems. And so straight on, we are going to define joint variation. This is a type of variation that relates three or more quantities, either directly or inversely, or directly and inversely. What do you make of this definition of joint variation? Point number one you want to take into account is that joint variation deals with three or more quantities, as the case might be. Okay? So in this case, we are no longer dealing with the relationship between two quantities. You will recall direct and inverse variation deals with the relationship between two quantities. But joint variation now will relate three or more quantities. Another important point you want to pick from the definition is the way in which joint variation relates three or more quantities. From the definition, it is said that joint variation relates three or more quantities either directly, that is to say that those quantities are related directly, or the quantities are related inversely, or you can have a situation where the quantities are related directly and inversely. But there is something I want to take note of here. Remember that I said that this variation relates three quantities. So we pick one of the quantity, and then we relate that one quantity to two other quantities, or even more than two quantities, as the case might be. Do you take that? Now let us assume that we have three quantities. Okay, pick one of them. That one quantity will be related to the other two quantities. Now, this one quantity can be related to the other one of the two, either directly, or it can be related to one of the two, either inversely, or it can be related to, the two guys, either directly and inversely. So that's the idea of joint variation. So one can think of something like x varies as y and varies inversely as z. So if you take note of this, x, its relationship with y is directly. Then when you relate it to z, it is inversely. It is also possible that you have x is directly proportional, that is, varies directly as y, and also varies directly as what? Z. So you say in that case, the relationship will be direct. Could also be that x varies inversely as y and inversely as z. So in such case, where you are treating the relationship between three or more variables, what deals with that is joint variation. Now we are going to move on straight ahead to how we analyze joint variation. No time to waste in this lesson, because the concept that we need to be able to handle joint variation, I already treated that under direct variation and inverse variation. Okay, so what we are just going to do here is using the knowledge of direct and inverse variation to now deal with the concept of joint variation. And so I would like us to consider this statement. Let us assume that x varies as y and inversely as z. Now the statement that x varies directly as y, can be written as x directly to y. That is the statement. The knowledge of direct variation explains this. So I advise you, please, if you have not taken the video lesson on direct variation and inverse variation, please kindly do so before you proceed with this joint variation. Even though you are done, you decide to proceed with this joint variation class, please remember to still take direct and inverse variation video lesson. It's going to help you a lot in this joint variation. Alright? Below this video lesson in the description box, you have the link to direct and inverse variation. And then towards the end of this video, alright, you're going to see an end screen that will lead you to those two types of variation that I treated previously. You can just tap on the end screen and it will take you directly to the tutorials on direct and inverse variation. Alright, x varies directly as y, it's written like this. Remember that statement also went further to say that x varies inversely as what? Z. In that case, you're going to have x varies inversely as z. Remember, in inverse variation, we have 1 over the other quantity. Now, in this first statement, x varies directly as y, and then x varies inversely as z, the second statement. We can now combine both of them. This is where the concept of joint variation comes in. Okay? We're going to combine these two variations we have on the board. Now, the question now is, how do we combine the two of them? We use the mathematical sign multiplication times, okay, to combine both of them. So from the first statement, you have x. From the second statement, you have x. So we're going to pick one of them. Are you following, right? I want to combine both statements jointly now. Then we have variation sign there, proportionality sign. I'm going to pick one of them, and then I will multiply these two quantities. You see, these two quantities are different. If they were the same, I will pick one of them. But now they are different, so what I'm going to do is to multiply the two guys, and that is going to be 1 all over z. This could still be written as y over z in this format, like we had previously stated. You can't solve any problem with this sign of variation, so we're going to remove it. And to remove it, you need to bring in equality sign and a constant of variation or proportionality. I'm going to use, as always, k. It's not compulsory to use k. You can use any other alphabet. The choice is yours. So this is going to be equal to, and then this is the constant of variation. That constant is going to multiply y over z. Now if you have k times y over z, it is simply ky all over what? Z. So you want to take note of this. That equation 1 is the joint variation, the combination of the first two variation statements you have. Remember, the way I presented this statement, x varies as y or directly as y and inversely as z. Here the joint variation is taking into account direct variation and inverse variation. Like I explained at the outset of these tutorials, joint variation could also be in such a way that it combines, two direct variation or two inverse variation is possible. I just decided to use the statement where one is direct and the other is what? Inverse. So once you're able to establish this, your problem is pretty solved. Your examiner will always give you initial conditions for you to determine the value of what? The constant of proportionality. And once you know the value of k, you can establish the relationship, the equation, the formula connecting the variables you have there, like in this case, x, y, and z. Like you've learned from previous tutorials on direct and inverse variation, once you know the relationship connecting the variables, you can solve any other thing that the examiner asks you to find. How important is joint variation? Remember, when I introduced the topic variation, I explained how important this topic is in other, scientific subjects, physics, chemistry, especially when it comes to scientific laws. Because some of the scientific laws we have are inverse relationship, direct relationship laws. Are you getting me right? So let me assume that I have a situation where direct and inverse is combined. There, joint variation can help us to understand that law. I'm going to give you a quick example. Think about this law under electric field, Coulomb's law of electricity. If you're a science student, in your physics, you're going to meet that law. Coulomb's law is a law that combines direct and inverse variation. It tells us that the force between two charges is directly proportional to the product of the charges. Directly proportional to the product of the charges. And inversely proportional to the square of the distance between the charges. You see, directly proportional first and inversely proportional. So to analyze that law, you need a good knowledge of joint variation. That is not all. What about Newton's law of universal gravitation? Are you following? We meet that law under a gravitational field, and that law tells us that the force between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance, okay, between the masses. Once again, that law is a joint variation law. So do you see a good knowledge of joint variation will help you to deal with that? Finally, I would like to draw your attention to one aspect of gas law in chemistry. There is this law we refer to as the general gas equation, where we establish P1 times V1 all over T1 equal to P2 times V2 all over T2. That law is a joint variation law. It's a joint variation law because we actually obtained that law from the concept of Boyle's law and Charles' law combined. I know that Boyle's law is an inverse law. Charles' law is a direct variation law. So these two guys put together jointly will produce that formula P1 V1 over T1 equal to P2 V2 over what? T2. Why did I draw your attention to this aspect of chemistry and physics? You see, you will enjoy science when you have good knowledge of mathematics. As a matter of fact, mathematics is the originator of this other aspect. In all sciences, we refer to maths as the father of science. Anyway, as I always remind you, please take this topic seriously to help you in other aspects of your science subjects. Now, there is something we usually do, and I would like to do it here. Let us assume that I make K subject of the formula. To make K subject of the formula here, I will cross multiply, you know that. If you cross multiply, you have Ky equal to xz. Then make a subject of the formula, you will get x times z all over y. X times z divided by y equal to k. Now what is the implication of this? In previous video lessons on direct and inverse variation, I already told you when you have a quantity equal to a constant, it gives you that room to write that quantity in its initial and final values. So can we apply that knowledge here? Since x times y all over x times z all over y is equal to constant, then we can write this as initial value of x, which is x1 times z1 all over y1 will be equal to x2 times z2 all over y2. And this could also continue. And of course, if you look at this is a form of general gas equation, P1 V1 over T1 equal to P2 V2 over T2. If we are to write, let's say, Coulomb's law, for Coulomb's law, we have that F, is equal to the constant of proportionality. Actually, there is 1 over 4 pi, permittivity of free space. So it's going to be Q1 times Q2, and then all over R squared. That's the law. Alright guys, this is pretty much about what you should know regarding joint variation development. Are you following, right? We're going to use this knowledge now to solve some questions. And I hope you're ready, right? Good. So let us get to our very first question, number 1. Alright, so we've got our first question here. The weight W in kilogram, kg, of a metal bar varies jointly as its length, L, in meters, and the square of its diameter, D, in meters. If W equals 140 when D equals 4 whole number 2 over 3 and L equals 54, find D in terms of W and L. Find D in terms of W and L. When you are asked to find a particular quantity in terms of another one, the idea is simply to make that quantity subject of the formula. But hey, there is something we need to do first. We are meant to use the values provided. Okay, this variation problem, we need to use the values provided to get the relationship connecting the 3 variables here in this question. Okay, so that is the first thing we need to do. Then we now try to make the subject of the formula in the relationship formula equation connecting the variables that we're going to get. So let us look at this once again. W of a metal bar, that's the weight. The question said varies jointly as its length. Varies jointly as its length. Now, were you told that the joint variation is direct or inverse? Was that statement used? No, it wasn't used. So once you hear varies jointly as its length, since inverse was not mentioned, are you following right? It simply means that the relationship between W and length is direct. So the weight of that metal bar will vary directly as its length. That's the implication of that first statement, varies jointly as its length. The question now goes further to say, and the square of its diameter. That is to say, that same weight, W, varies jointly as the square of its diameter. Once again, there is nothing like inverse here. We were not told that varies inversely or maybe and inversely as the square of the diameter. There is nothing like inverse there. So the implication is simple, that the weight W will be directly proportional, will vary directly as the length and again directly as the square of its diameter. Please, you want to take note of this, very important. If it is inverse, that term inverse will be used. Following this explanation, we are simply going to write that W varies directly as length, okay, and that same W varies directly as square of its diameter. Take note of the special term used here, square. So this is going to be D squared. And of course, with this, you combine these two statements jointly, pick the weight W from both of them, pick one of them, pick your variation sign, and then multiply L and D squared. If you do that, you're going to get this. The implication will now be that W is equal to, remember you're going to remove the sign of proportionality and then introduce equal to and a constant. Let me use K once again as a constant, use it to multiply LD squared. So this is what we are going to work with. That the weight W of the metal bar is equal to a constant of proportionality, whose value we don't know, multiplied by the length of the metal bar, multiplied by the square of the diameter of the metal bar. Now we are going to hit this directly. I will not define the parameters. But please take note, you are expected, if it is in theory case, to bring out these values you have here. For example, W is 140, D is 4 whole number, 2/3, and L is equal to 54. You don't know your K. Alright, so the first thing we are going to do is calculate our K using those conditions provided. So W is going to be, let's substitute now. In place of W, we fix 140, and that's going to be equal to the constant of variation K we don't know. So you maintain it, multiply by the length. The length given in the question is 54. Then multiply by D. D here is 4 whole number, 2/3. And I told you that whenever you have a mixed fraction, you're solving a problem, please change that mixed fraction to improper fraction. We've solved a problem like that in previous classes. This is going to be 3 times 4, which will give you 12, plus 2, which will give you 14. So this is going to be 14 all over 3. Take note that in our formula here, look at it, the D, the diameter is squared. So I'm going to square this term. So solving for K, we are going to get 140 equal to K times 54, then times, you are going to open up that bracket with the square. Are you following right? Now 14 squared is going to give us 14 times 14, which of course should be 196. So we'll have 196. That's going to be divided by 3 squared. 3 squared will give you 9. Now with this you have here, you know that this 9 will divide this 54. If 9 goes into 54, you will get 6. You will get what? 6. Alright, so that this is going to give us 140 equal to, let me continue here, 140 would be equal to K times 6 times 196. But I don't want to multiply this place. I have to believe we have gone past that level. Now if I have K times 6 times 196, you know that I will get some value. 6 times 196 will give me a value which will multiply K. And that will be equal to 140. You know, from that level, you are going to divide both sides by what is multiplying K that you are looking for. So here, what is multiplying K is 6 and 196. Multiplication is between them. So to get K directly, I guess I should just do that. To get K directly is going to be 140 all over 6 times 196. Now, I've already explained that it is better to solve with something like this so you reduce easily. And I want us to reduce as fast as we can. I've got no calculator here. So we're going to work on this and see. 2 divide 3. 2 divide 6 will give us 3. 2 into this will give us 70. And of course, we can still reduce this, we know. 196 and 70. 2 can go into 196. You are going to get 9. If 2 divides 19, it's going to be 9 remainder 1. And of course, attach the 1 to this, you get 16. And then 2 into 16 will give us 8. 2 will divide this 70, and then we get 35. Alright, we get 35. And let's see, can this still reduce? 5 can divide this, but 5 can't divide this. And 7 cannot. Let's see, can 7 divide 98? Yes, 7 can divide 98. If you want to find out whether 7 can divide 98, you use the rule of divisibility. Are you following, right? And how do you know whether a number can be divided by 7? Let me quickly mention this. Follow along. You know, this is a real learning class, like I've always told you guys. From Jamb 41 here, you get the best you could ever always wish for. Are you getting me right? Now, how would I know that 7 can divide 98? There is a reason why I'm thinking of 7 already, because I know that 7 can divide 35. To find out whether 7 can divide 98, multiply that last digit by 5. That last digit is 8. 8 times 5 will give you 40. Are you getting me right? Multiply the last digit by what? 5. Anything you get, add it to the remaining digits. 5 times 8 will give you 40. 40 plus 9 will give you 49. Then ask yourself, can 7 divide 49? If 7 can divide 49, it simply means that 7 can divide this whole 98. Is that okay? And of course, 7 can divide 49, we know. If 7 goes into 49, you get 7. So clearly, 7 can divide this guy. Let's do that and see. If 7 divides this 98 first, 7 goes into 9, it's going to give us 1 time remainder 2. Attach the 2 to this 8, you get 28. If 7 divides 28, it's going to give you 4. So 7 can divide 98 to actually give you 14. 7 can divide 35 and you get what? 5. So I've been able to reduce this, and I guess with this, nothing can divide again. So I can conclude that my k, constant of variation, is equal to 5 in the numerator, all over 3 times 14 in the denominator. And 3 times 14 will give you what? Then 3 times 4 is 12, right? To carry 1, and then 3 times 1 will give you 3 plus the 1, you get 4. So this is going to be 42. The implication of this is that our constant of proportionality is 5 over 42. Now we are going to establish the relationship, the equation, the formula connecting these 3 variables W, L, and D. Okay? Once we establish that relationship, our problem is solved. We will now make the subject of the word formula, because the examiner said we should find D in terms of W and L. I hope you are ready for that. Okay, so we are going to proceed. This k we got 5 over 42. We'll come back to this equation and fix it. W is equal to, it's going to be 5 over 42 LD squared. Alright, I hope this is making sense to you, right? If you are here to subscribe to Jamb 41's YouTube channel, how about you pause this video in a moment, then hit the subscription button, subscribe to this channel. Turn on the notification bell so that once I upload any new content, you will be personally notified. And remember, you can become Jamb 41's channel member. Just below this video lesson, you will see the Join tab. Click on that Join tab. The Jamb 41's packages will appear. Alright? Select whichever that is convenient for you. Support this channel, and so that we'll continue to give you the best. If you become a channel member, you'll get even much more benefits that are specifically for our channel members. Alright? Okay, so let us move on. Like I said, we are going to come back to this equation W equal to KLD squared, fixing the value of that constant of variation. So the implication is that the weight of the bar W will be equal to, then we fix 5 over 42 for K. So this is 5 all over 42 multiplied by LD squared. So this is going to be LD squared. Now the examiner asked us to obtain D in terms of W and L. Meanwhile, take note please, this is the relationship, this is the equation, this is the formula connecting the variables. With this formula, you can solve any other thing that the examiner chooses to ask you from here. Alright, you know, sometimes with this information here, your examiner can ask you, okay, fine, find the value of D when L is and W is, you are giving values of L and W. Or find the value of W when L is and D is, they give you the value of L and D. In either case, you can simply use this equation, this formula, this relationship connecting the 3 variables here, okay? So this is very important, take note of that. Alright, let's proceed. So find D in terms of W and L simply means make D subject to the formula. Make D to stand alone. And how do we achieve that? Please come along, let's play around with that. Now this is our D. We are going to make this D to stand alone. Are you following right? Now if you look at this equation, this is the same as W equal to 5LD squared. Everything all over 42. Since the mathematical sign between 5L and D is multiplication, we could simply write this as 5LD squared all over 42. This is what I mean. Something like W equal to 5LD squared all over 42. So that if you take note of this, D you want to make subject to the formula is in fraction form. And since what you are looking for is in fraction form, by the principle of simple equation, you are expected to cross multiply. Don't forget that. You are looking for something and that is in fraction form, you are expected to cross multiply. Meanwhile, when it is in single fraction form, remember we have only one division sign all over. There is no plus or minus separating two fractions, okay? It's just one division sign because this is multiplication of 5 and L and D squared. For that reason, we cross multiply. So cross multiply, we are going to get 5LD squared all multiplied by invisible 1 that is under this W. And that's going to give us 5LD squared. And that is going to be equal to W times 42, which is 42W. Remember, we are making D subject to the formula. Now, what you are looking for, which is D, has 5L multiplying it. And if you divide that by 5L, you'll be left with D squared. That's going to be equal to 42W divided by 5L. Once again, you divide here by 5L, divide here by 5L. 5L will, divide through, cancel out, you'll be left with D squared. Then, to obtain D now, you see this is D squared. To obtain D, you have to remove this word, square. And how do you remove square? You take square root. If I take square root of this D squared, you're left with D. That will be equal to, you take square root of this term, and this is going to be 42W all over 5L. 42W all over what? 5L. And of course, we have obtained D. We have found D in terms of W and what? L. We have simply made D subject to the formula. We have simply expressed D in terms of L and W because these are various terms or statements that the examiner can use. Find D in terms of W and L. Express D in terms of W and L. Make D subject to the formula. These three statements, they are the same. Your examiner decides whichever to use for you. Are you following right? And this is the value of D written in terms of W and L. I hope you understand that, right? With what we've done here, you see clearly that the correct option is option what? B. Option B is the correct answer. Did you enjoy this video lesson? That's good. If you do, which I believe, please give Jamb 41 thumbs up. Don't forget to share this video lesson. Are you following right? To your friends, to your schoolmates. Alright, they need this video lesson. Remember, variation is one key topic that every science student, alright, is expected to get used to. You don't joke with it. It has a lot of application in other aspects of science subjects. Alright, this is interesting. We are going to pick another question and then solve for this joint variation once again. Question number 2.